Next topic is a discussion on application properties of surfactants. This includes wetting, foam generation, and detergency. Wetting. The character of surfaces is determined by their hydrophobic or hydrophilic character. Hydrophobic surfaces like surface of plastics, which are low in energy. On these surfaces, the water basically appears as spherical uh, particles, and so these surfaces are poorly wetted, hydrophobic surfaces, and the water on these surfaces basically rolls off. In hydrophilic surfaces, high in energy surface of glass, for example, the water covers the surface as a film. So here is the contrast between the two properties. This is a hydrophobic surface. Water is beading up or rolling off here. And in hydrophilic surface, the water is basically forming a film. And this can be quantified. A drop of water on every liquid or every solid surface forms a characteristic angle here. So this water on this surface of this particular substrate forms a certain geometry and an angle with the surface. We call that contact angle. This contact angle is related to the interfacial tension between solid and air and surface tension of liquid by Young's equation. And this contact angle can be viewed and actually measured experimentally. Contact angle of 180 implies no wetting. Basically, a sphere appears on the surface of substrate, and contact angle of 0 implies complete spreading. Basically, a film appears on the surface of the substrate. This can be quantified, this whole process can be quantified by Young's equation, which leads to a determination of spreading coefficient. So we can basically compare different liquids and effect of surfactants on wetting. And here is this effect of surfactant is clearly shown here. We have some fiber here, cotton fiber that is placed on top of water, pure water. And in this case, this cotton water is not wetted. And kind of just sits on top of water. If we add some surfactant, then absorption of surfactant on the surface of these fibers improves wetting, and this kind of a cloth sinks inside. Same thing happens with polyester fibers. So conclusion is that surfactants significantly improve wetting properties. This is very important because wetting is the first step in detergency and cleaning. Here, this can be measured. This sinking time can be measured, and the effect of surfactants on wetting time can be measured. We can take a strand of a cotton fiber and make different solutions and look at the sinking time of that fiber. And as you see here, things like the anionic surfactants like linear alkyl benzene sulfonate have a wetting time of 15, alcohol ethoxylate about 25, about 18, amine oxide 25. So we can basically look at the effect of different surfactants on wetting, an important factor in detergency. In terms of cleaning properties, wetting and interfacial exchange are fundamental requirements for effective washing and cleaning process. The mechanism of lifting of oily soils is based on adsorption of water and surfactant, which results in this rolling up mechanism. So if this is the initial state of an oily soil on a given substrate, it can be a dish or a fabric. As we soak this in surfactant solutions, the contact angle keeps increasing, and eventually complete sphere is here, and basically the oil is removed from the surface. This mechanism is known as rolling up. It's an important for oil removal of oily, greasy soils. Here is a schematic of a complete cleaning process. As you see here, initially you have this dirt, can be greasy or particulate soil on a given substrate. When we place this in detergent solution, surfactants are adsorbed on the surface of substrate and on the surface of this soil, and the reduction of surface and interfacial tension causes loosens the soil and causes it to be removed. And eventually the soil is basically dispersed and emulsified when it's surrounded by additional surfactants, and basically can be rinsed out. And so we finally end up with a monolayer of surfactant on our substrate, which again during rinsing process is removed. So this is how surfactants have become the workhorse of detergents and cleaning products because of their efficiency in soil removal. Here's another schematic that shows this detergency process. Again, the adsorption of surfactants on soil and substrate facilitates soil removal. Another picture here of the same phenomena. Initially, the soil particles on the substrate, surfactants adsorb on soil particles and on substrate and facilitate soil removal, attachment. A few words on foams. One of the things that surfactants, soaps and surfactants are very good at is generating foams. The foam generation, the mechanism of that is shown in this schematic. Basically, if these are basically in pure water, there is no foam. No matter how much mechanical energy we apply, there's no stable foam applied. But once we add some surfactants, even at dilute concentrations, low concentrations, we get bubbles form, and then these bubbles are stabilized by adsorption of surfactants on this film that surrounds the bubble. So basically, surfactants adsorb with their hydrophilic part inside the film, hydrophobic outside on both sides of this bubble, and provide a sort of like a skin to stabilize the foam. Here is a magnified schematic on what is inside that film in the bubble. We can have surfactant monomers, we can have micelles. So it's very thin, but thick enough to include surfactant molecules and surfactant aggregates. We can measure this, we can quantify this. Foam volume can be measured by a method, ASTM method known as Ross-Miles foam test. And foam stability can be uh, analyzed by a variety of techniques, soil titration technique, tergotometer test, dishwashing test, and so forth. Here's a schematic of a Ross-Miles foam volume test. Basically, what we have is a dilute solution of surfactant this is a cylindrical glass tube, and about 5 centimeter in diameter and 90 centimeter in height. We place some surfactant solution at the bottom, and then the remainder of the solution is placed on top, and the valve is open, and the liquid drops on this solution and generates foam. And then we basically measure the height of the foam and use that as an evaluation of the surfactant efficiency in foam generation. Here are some numbers. Alkyl sulfate has foam height of 140, alkyl ether sulfate 200. So these are generate fairly high foam. That's why these surfactants, these anionic surfactants, are used in dishwashing liquid and shampoos, where consumers prefer high sudsing capabilities. On the other hand, the non-ionic have fairly low foam volumes. Alcohol ethoxylates here, for example. So we can actually measure and determine foam generation efficiency of each surfactant system.